Hello, welcome back. In this video, we're going to go through an example where we're going to use most of the tools that we developed so far in this course. We're going to use pre-calculus. We're going to use the first, second derivative tests. We're going to use the limiting behavior. So at the end, we're going to bring all the pieces together and we will observe all nice behaviors of the function in the graph of the function. And here are the guidelines for analyzing the graph of a function. And the first two items are sort of like things that we did in the pre-calculus section, except the asymptotes, because we have just learned in this chapter how to find a horizontal or slanted asymptote. What we were doing in pre-calculus was essentially finding vertical asymptotes. So this is new, at least for the calculus side of this question. And domain and range would be pre-calculus, intercepts pre-calculus, and symmetry is pre-calculus. And in the last step, we're using all the tools that we developed in chapter 4, which is the application of differentiation. So in fact, we're going to use the first derivative test, second derivative test, and the test for increasing or decreasing behavior, and the test for the concavity of the function. So we're going to bring all the pieces together to determine if we have relative extrema or points of inflection. All right, I list the 4 items: domain, range, intercepts, and symmetry from pre-calculus. So we have a rational expression. The top is a polynomial. The bottom is as well a polynomial. The domain is all x's. That does not make the bottom if x squared minus 81 is 0. Well, in fact, yeah, x squared minus 81 is 0 for x equals plus or minus 9. So I got to exclude those points from the domain. The domain is all x's from minus infinity to minus 9, minus 9 to 9, and 9 to infinity. And the range for this function is, in fact, the top is coming with a higher degree than the bottom. So you can achieve anything and everything. So I'm going to write here that the range is minus infinity and infinity here. Third item in the checklist is the intercepts. So let's start with the x-intercept. I'm going to solve x cubed divided by x squared minus 81, 0. Well, rational expression, and then I can make this look like a rational expression by dividing by 1. And do the cross product, you get x cubed equals 0. Right? X cubed equals 0 by using the cross products. Right? So that implies x equals 0. And if x equals 0, go back and plug that back in here. So x-intercept is in fact the origin. Okay? Well, in the y-intercept, we plug in 0 for x and then check the corresponding function value, which we just did. So y-intercept as well is the origin. The graph of this function is going to cross the x and y axis at the origin. Recall that we have 3 different types of symmetries: x-axis, y-axis, and the origin. And in each case, we do some change of variables and see if the function description changes or not. So in the first one, we have x replaced by x, y replaced by negative y. In y-axis symmetry, we have x replaced by negative x, y replaced by y. For the origin, we replace x by negative x, y by negative y. Well, at this moment, stop the video and try each case and convince yourself that we have the symmetry about the origin. And then the left-hand side is minus y. But this, if you multiply both sides by minus 1, you get y equal x cubed divided by x squared minus 81, which is exactly the same of this function description. We have 3 different types of asymptotes. So here's a tip for you. So horizontal and slanted asymptotes are sort of like related to the behavior of the function at infinity, and vertical asymptote is the behavior of the function at a finite point. Whenever you see a rational expression coming with the degree of the top to be greater than the degree of the bottom, you most probably have a slanted asymptote. And if the degrees of the top and the bottom are the same, so you're talking about a horizontal asymptote. Even in the case like the degree of the top is lower than the degree of the bottom, you still have a horizontal asymptote. So in this case, the degree of the top is greater than the degree of the bottom, so it's likely that we have a slanted asymptote. So for the vertical asymptotes, essentially we're looking for x's that make the bottom 0. And in fact, I have just shown that x equals -9 and x equals 9 are not in the domain for that reason. In fact, they are vertical asymptotes, okay, because the function blows up. Gets larger and larger when you get closer to those numbers. For slanted asymptotes, we're going to do a long polynomial division. Okay, let me just explain that to you. All right, I'm going to divide x cubed by x squared minus 81. I'm going to put an x here. All right, so this becomes x cubed minus 81x. Do the subtraction, x cubed terms are canceled, you have 81x. Y can be written as x plus 81x divided by x squared minus 81. I have two pieces of the function, one is x and the other one is the rational piece. And if you look at the degrees of the top and the bottom, so this one has the degree 1, this one has the degree 2. So in terms of the limit of this function at infinity or minus infinity, so this will tend to, right, the degree of the top is less than the degree of the bottom. What is going to govern the behavior of y is this x term here. All right, y equals x here. We call that to be a slanted asymptote. And let's try to determine the behavior of the function on the left and on the right of these two points, which are not in the domain. All right, we're going to look at those 4 limits just to see how the behavior of the function is on the left and on the right of -9 and 9. So let's just really do that. If you're on the left of -9, you're talking about points -9, 0.001 maybe, or 0.0001. So when you plug that back in here and take the square of that number, it's going to be bigger than 81. So the bottom is going to be positive, whereas the top is the cubic power of a negative number. That has to be negative. So in other words, this will go to infinity because the top is, the degree of the top is bigger than the degree of the bottom, but it'll go to minus infinity. Let's look at this one readily again. So you're on the right of -1. So you're talking about points -8.99999. If you take the square of that and subtracts 81 from that, so you will have this term to be negative, whereas x cubed is still negative because you're talking about negative numbers. So in turn, this will be positive, but positive infinity. Pause the video and go ahead and check those limits by yourself. That's a good warm-up exercise for you to practice the same thing I did in the video. So eventually we're gonna use those limits when we try to graph the function. All right, to sum up, we have a slanted asymptote y equals x line, and we have vertical asymptotes x equals 9 and -9, and no horizontal asymptote. All right, so now we're looking at the item number 3 in the guideline. So we're looking for y prime and y double prime. So let's find the y prime together. And then you're going to pause the video after I'm done here and work on finding y double prime by yourself. So, well, since we have a quotient here, why don't we use the quotient rule? The bottom squared. All right, so this turns out to be 3x squared times x squared minus 81. So this term here, 3x squared times x squared, is going to cancel this term, but I have only 2 of that. So in turn, I have x to the 4th minus 243 x squared, all divided by x squared minus 81 squared. And now pause the video and try to come up with y double prime by applying the quotient rule again to these 2 pieces. And here we go. Y prime is the one that I found. And then you did your work. Hopefully you got everything reduced to this simple form here after many cancellations.